Welcome to function transformations, finding the equation. The first thing that we need to do is determine what type of function we're dealing with. And here, when I look at the graph that we're dealing with, on the left-hand side here, I can see that that is the absolute value function. So I'm just going to remind you that's f of x is equal to absolute value of x. Now I'm going to start off by looking at the graph of that and think about how is that transformed in order to end up with the picture that we saw on the left there. So one thing is that clearly it's being reflected. So I'm going to draw that reflection. And I'll do that with a different color. So draw the reflection here. And that is a reflection through the x-axis. And we accomplish a reflection through the x-axis by saying negative f of x. Now, if you don't know that, then you need to review the introduction to function transformations. And then the next thing that we see here is that this function is moved 1, 2, 3 to the left. So what happened to f of x now? F of x is now negative f, and then 3 to the left means plus 3 is going to move me 3 to the left. And then again, if you don't know that about function transformations, you need to get an introduction to function transformation or review that. But plus 3 moves the graph to the left. So given this information, moving from here, from f of x to negative f of x to negative f of x, negative f of x plus 3, that's going to yield a final result. And I won't call it f of x, because f of x is already taken, right? F of x, I've already said, is the absolute value of x. So I'm going to give it a new name. I'm going to say that my final function is g of x, and that is going to be the opposite of the absolute value of x plus 3. And you can see where everything came from. The absolute value of x there. The absolute value of x. This absolute value comes from that absolute value. This negative here, if you go all the way to the left, it comes from that negative. Or really, I guess initially it came from this negative in the middle. And then this plus 3 is all carried forward to our final equation. Okay, so let's look at another one. Now this one, we're recognizing, hopefully, the radical function. And I like this way of doing, this way that I'm doing it, where I keep track of everything, all of the steps. So I'm not trying to do it all at once. So f of x is this, and I'll go, I know when x is 4, f of x is radical x. So let's graph that. When x is 4, I know that y is 2. I know I've got 0.00, and I know I'm going to have 0.11. So I'm trying to get a fairly accurate graph here of the radical function. Now, how is that operated upon to end up with this function that we see down below it? So how do I operate to get to that? That's our objective. And if we reflect this through the x-axis, we're going to get this, and that is going to be negative f of x. confuse that with the dashed line that I have there. Negative f of x, so that's a reflection through the x-axis. Then if I reflect over here through the y-axis, that's going to give us negative f of negative x. Now I'm going to have some horizontal and vertical shifting, and I think I can take that all in one step here. I don't have to do two different steps for that necessarily. Where I end up here, right? And that's going to be negative f of negative x, and I'm going to the right, so that is going to be minus 3, but I have to be careful about that. I have to have that factored, so the x minus 3 is going to be factored in there. So are you catching that? In order to have the correct horizontal transformation here, x minus 3, the negative has to be factored out. So the minus 3 is going to move me to the right, but only if I have that factored out. I think this is important enough to take a little, compare this to what the incorrect one would be. So if I were to do negative f of negative x, and then I say, oh, that's going to go to the right, so I'm going to go minus 3. All right, that's going to be wrong, because in order to find the horizontal shift, the negative has to be factored out. So that would be, this one would be plus 3, so that would be to the left. Okay, so that's a little detail to be careful of. It only comes up with the radical functions when we're doing the radical function transformations. And then finally, what else did I have here? I had the minus, what was that, minus 4 down, it looks like, minus 4 down. Okay, so we can finish up here and get the final equation. So we're going to call it a g of x, and that's going to be equal to, let's see, I've got the opposite of x minus 3 minus 4. So there kind of are two things going on with these types of problems. One is we're trying to get to this final transformation of f, and then we have to merge that with the parent function in order to get the correct final expression. And an excellent way of checking these, an excellent way of checking that I got this correct, would be to go ahead and graph this on a graphing utility and see if I end up with the original picture, which I was given over on the left here. So look to the left, and that picture there, that's what we want to end up with. All right, so hopefully you can find the graphs now of functions that are transformed, especially, specifically functions that are from the library of functions that you know.